So the first thing that the Greeks really did very well was to explore eclipses. And once you know the diameter of the Earth, if you look at lunar eclipses, and this illustration shows it very well, you can actually measure essentially, well, one thing is the apparent angular size of the moon on the sky. That's about half a degree. That's very easy to measure, and you can measure it at any time. But also during the eclipse, you can actually measure the angle, the apparent angle, essentially the distance from the moon at the onset of the eclipse, and then also when the moon ends the eclipse. It turns out that this angle phi is basically 3 times theta. Theta is the apparent size of the moon in the sky, which is 0.5 degrees. So essentially 1.5 degrees. But more importantly, the fact that phi is about 3 times theta implies that the diameter of the Earth is about 3 times the diameter of the moon. And what this really allows you to do is figure out what is the distance between the Earth and the moon. So the ingredients, the 3 key ingredients that you need is, one, you need to know the diameter of the Earth. And we can do that with the experiment that we've just covered. And then we need to know the apparent size of the moon. And finally, we need to have a comparison between essentially what is the size of the Earth and the moon, which we can do during an eclipse. So up to now, to summarize, we've seen that we can determine the size of the Earth, not even leaving our planet, the size of the moon, and also the distance from the Earth to the moon. The final distance that we can actually determine with these very classical methods of just measuring angular sizes on the sky and looking at essentially angles where the sun hits the surface is the distance from the Earth to the sun. Classical way to determine the distance from the Earth to the sun is not to explore an eclipse, but actually to explore 2 key positions that you can see essentially on this diagram. When the moon is on the last quarter or the first quarter. At those positions, we actually know that this angle theta that you can see here is 90 degrees. This is by definition. This is the definition of the first or last quarter. So what we need to do is to measure this angle phi. So essentially the angle between the sun and the moon. If we do that, then because we know that the sum of the angles of any triangle needs to be 180 degrees, we can figure out something we're looking for, which is this angle alpha. So it turns out that if you do this measurement, it ends up being something like 89.85 degrees, implying that alpha is a really small angle. So that's just 90 degrees minus 89.85, which in radians corresponds to the value that you can see here. That's 0.0026. You can actually calculate this ratio between the distance between the sun and the Earth and the moon, which is 1 over alpha, essentially at just 1 over alpha in this case, because the angle is so small that you can use the small angle approximation, or if you're really keen, you can use just sine alpha. The value will be the same because the angle really is incredibly small. And the great advantage of this is by covering the methods of first determining the size of the Earth, then the distance between the Earth and the moon, and the size of the moon. Finally, we can actually compare the distance between the sun and the Earth and the moon. And because we determine the distance between the Earth and the moon, we can finally determine what is the distance between the sun and the Earth. And this is what is defined as 1 astronomical unit, or rather, this is how you would define it with sort of classical methods. And just to recap, all you need to measure actually is the diameter of the Earth that we can do from the ground with some simple experiments, the angle that you can see above, which is very small, that's alpha, and finally the angle that the moon subtends on the sky. And if you do that, you can determine what 1 AU is. And that's, I think it's pretty cool that without leaving the Earth, 2,000 years ago, we could already determine what 1 AU was based on some simple observables.